In this video, I am going to explain the concept related to inverted R-2R ladder. Inverted R-2R ladder. Block diagram. First one is block diagram. Block diagram of inverted R-2R ladder. We use ladder network. 2R R 2R R 2R R-2R. This one is 2R. One more 2R is connected to ground here. This one is ladder network. VR here. VR is connected to like that. These are the switches. D1, D2, D3, D4. This one is DN. The current flow through this 2R is I1. Here I2, I3, I4. This one is IN. Corresponding node voltages are here. This is the node voltage. VR by 2 power 0. VR by 2 power 1. VR by 2 square. VR by 2 cube. At this point, VR by 2 power n minus 1, where n is called as a number of bits in the data, digital data. The digital data is in the form of D1, D2, D3, D4 up to so on and so forth, Dn. This one is D1 is MSB. Dn is LSB. In previous case, weighted register DAC, digital to analog converter, and R-2R ladder type digital to analog converter. LSB and MSB positions are different. In previous case, in previous two cases, this one is MSB, this one is LSB. In this case, the positions are interchanged, MSB and LSB. That is the first important point. Op amp, we use op amp is in inverting configuration. Minus plus. This is the output voltage V0 respect to ground. Here two lines are there. One is inverting terminal. Non-inverting terminal. This one is switch. Switch. All these are switch ends. The switch is connected to either logic 0 or logic 1. D1 is logic 0 connected to one of these lines. D1 is at logic 1 connected to one of these lines. I will explain clearly. These are the switch positions like that. This one is non-inverting terminal of the op amp is connected to ground. This is the virtual ground concept. Here 0 volts. Inverting terminal is also connected to 0 volts like that. This is the block diagram of inverted R-2R ladder network. Here I1, find out I1 value, I2 value, I3 value here. IX, IY, IZ, IX, IY, IZ like that. Here data word is represented as a DI, where I is equal to 1, 2, 3, and so on and so forth n, where n is called as a number of bits in this data word D1, D2, D3, D4, and so on and so forth Dn. Di, where I is equal to 1, 2, 3, that means D1, D2, D3, and so on and so forth. Dn is at logic 0. Is at logic 0. That means D1, D2, D3, D4, and so on and so forth up to Dn is at logic 0. Logic 0 means the switch here. These are the switches. The switches are the switches of DI are connected to this point. The switches of DI, that means I is equal to 1, 2, 3, 4, and so on and so forth n. That means D1, D2, D3, D4, and so on and so forth. Dn is connected to this one. That is at logic 0, ground potential. Next one, D1, D2, D3, and so on and so forth. And Dn is at logic 1. Logic 1, the switches of Di. That means Di means I is equal to 1 to n. D1, D2, D3, D4, and so on and so forth. The Dn switches connected to this point. Connected to this point. That means inverting terminal of the op amp. Inverting terminal of the op amp is also at a virtual ground potential. In both the cases, whether Di is 0, Di is 0 means D1 is equal to D2 is equal to D3 and so on and so forth. The Dn is equal to 0. Or Di is equal to 1 means D1 is equal to D2 is equal to D3 is equal to Dn is equal to logic 1. In both the cases, the switch endpoints are connected to ground potential. Ground potential. Therefore, the current I1 and I2, I3, and I4 equally distributed. The currents I1, I2, I2, I1, I2, I3, and I4. Now I will calculate currents I1, I2, I3, and I4. I1 is equal to, here I1 is equal to VR by 2 power 0 by 2R. 2 power 0 is 1, VR by 2R, VR by 2R. This is the I1 is the current flow through this 2R resistance. Here the ladder node voltage are representation is like that. VR by 2 power 0, VR by 2 power 1, VR by 2 square, VR by 2 cube. Last one is VR by 2 power n minus 1. Now calculate Ix. Ix is equal to this voltage VR by 2 power 0 minus VR by 2 power 1 by R. Therefore, find out Ix voltage. Ix is equal to VR by 2 power 0 minus VR by 2 power 1 is 2. That is equal to VR minus VR by 2 by R. 2 VR minus VR. That is VR by 2R. VR by 2R is I1. Therefore, Ix is equal to I1. Now find out I2. I2 is equal to the node voltage is here is VR by 2 power 1, that is VR by 2 by 2R. VR by 2 by 2R. That is equal to VR by 2R by 2. VR by 2R is I1. I1 by 2. Therefore, I2 is equal to I1 by 2. Next, calculate Iy. Iy is equal to VR by 2 minus VR by 4 by R. VR by 2 minus VR by 4 by R. That is equal to 2 VR minus VR by 4R. VR by 4R. VR by 2R by 2. VR by 2R is I1 by 2. Therefore, Iy is equal to I1 by 2. Iy is equal to I1 by 2. Therefore, I1 is split into equally at this node I1 by 2 and I1 by 2. Therefore, I1 is equal to I1 by 2 plus I1 by 2. Next one at this node I3. I3 is equal to VR by 4 by 2R. I3 is equal to VR by 4 by 2R. Here the node voltage at this point is VR by 4. VR by 4 by 2R. That is equal to VR by 8R. VR by 2R by 4. VR by 2R is I1 by 4. Here I3 is equal to I1 by 4. I1 by 2 is divided into I1 by 4 and also I1 by 4. This is IZ is also IZ is equal to I1 by 4, obviously. At this node, Iy is equal to I3 plus Iz. Iy is equal to I3 plus Iz. Find out Iz. Iz is equal to Iy minus I3. Iy is I1 by 2. I3 is I1 by 4. That is 4. 2I1 minus I1 by 4. That is equal to I1 by 4. That is equal to I1 by 4. The currents are division. The currents are divided like that. The current division is like that: I1, I2, I3. This is I1. I2 is I1 by 2. I3 is I1 by 4. I4 is I1 by like that. I1 by 8. Like in that fashion, the current is divided. The current here, the node voltages are fixed. VR by 2 power 0, VR by 2 power 1, VR by 2 square, VR by 2 cube, VR by 2 power n minus 1. The node voltages of that ladder network is fixed one. The current flow through this 2R resistance are also fixed one. And it is independent of the switch positions. That is independent of switch positions means D1 is connected either this point or this point. D2 is connected to either this point or this point, and so on and so forth. Dn is connected to this point or this point, whatever it may be. The switches are connected to ground potentials. The switches are connected to ground potentials. Here important, the equal division of current in successive nodes remains the same in the inverted R-2R ladder, irrespective of the input binary word. The important property here, I1, I1 by 2, I1 by 4, and I1 by 8. I1 is divided into I1 by 2 and I1 by 2. Here this one is resistance R, this one is 2R, this one is R. This is the current I1. I1 is divided like that, I1 by 2 and I1 by 2. This one is 2R, this one is R. I1 by 2 is divided into I1 by 4 and I1 by 4 like that. The circuit has the important property that the currents divides equally at each of the nodes. Equally divides. I1 is divided into I1 by 2 and I1 by 2. Equal currents. I1 by 2 is divided into I1 by 4 and I1 by 4. This is the important property. The circuit has the important property that the current divides equally at each of the nodes. At each of the nodes. One important point. The equal division of current. Another important point here is the equal division of current. The equal division of current in successive nodes remains the same in the inverted R-2R ladder, irrespective of the input binary word. Irrespective of the input binary word. The equal division of current in successive nodes. I1 is divided into I1 by 2 and I1 by 2. I1 by 2 is divided into I1 by 4 and I1 by 4. I1 by 4 is divided into I1 by 8 and I1 by 8. Remains the same. Successive nodes remains the same in the inverted R-2R ladder, irrespective of the input binary word. Irrespective of the input binary word means all are zeros, all are ones. In either case, the switches are connected to ground potential. Irrespective of that, binary word. Constant current flow through these 2R resistance. The current remains constant in each branch of the ladder. This is the branch 1, branch 2, branch 3, like that. In each branch of the ladder, the current remains the constant because the ladder node voltages are fixed. VR by 2 power 0, VR by 2 power 1, VR by 2 square, VR by 2 cube, VR by 2 power n minus 1. Another important point here is the current remains constant. The current remains constant in each branch of the ladder. In each branch of the ladder, because the constant current implies constant current implies constant current implies constant voltage at the constant implies the constant voltage. Implies the constant voltage maintained at a ladder network nodes. Ladder network nodes. That means VR by 2 power 0, VR by 2 power 1, VR by 2 square, and so on and so forth. VR by 2 power n. These node voltages are fixed. Therefore, the current flow through the 2R branches is also fixed one. The current flow through the 2R branches is also fixed one. When the switch DA is at a logic 0, important point here is when the switch DA is at logic 0 means D1, D2, D3, Dn are at logic 0. The switches are connected to these points like that. The switches are connected to these points. That is, these points, this point means connected to ground potential. Non-inverting terminal of op-amp is connected to ground potential. This one, not pink lines. These pink lines are connected to ground potential. That means non-inverting terminal of the op-amp. When D1 is equal, D2 is equal, D3 is equal, Dn is equal, logic 0. When D1 is equal, D2 is equal, D3 is equal, Dn is logic 1. The switches endpoints connected to these lines. That means inverting terminal of the op-amp. This inverting terminal of the op-amp is also connected to ground potential because of the virtual ground concept. In either case, DA is equal to 0, logic 0, or DA is equal to logic 1. The switches are connected to ground potentials. Virtual ground. Due to virtual ground, inverting terminal of the op-amp is also maintained at 0 volts. There are some important points related to inverted R-2R ladder. The circuit works on the principle of summing currents, and it is also said to be operated in the current mode. Another important point here is circuit works on the principle of summing currents. And is also set to operate in the operated in the current mode. This is the ladder network. Ladder network node voltages are VR by 2 power 0, VR by 2 power 1, VR by 2 square, VR by 2 cube, and so on and so forth, VR by 2 power n minus 1. These ladder network node voltages are fixed. The current flow through these branch resistances 2R, 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 and 2R are also constant. I1, I2, I3, I4, and IN are all constant because these node voltages are constant irrespective of the digital data is applied at the switches. Whether either D1 is equal, DA is equal to logic 0 or DA is equal to logic 1. That means D1 is equal to D2 is equal to D3 and so on and so forth. DN is at logic 0 or D1, D2, D1 is equal to D2 is equal to D3 is equal to D4 is equal to DN is equal to logic 1. In either case, the switches are connected to ground potentials. The switches are connected to ground potentials. This is the total current IT. This is the total current IT. When another important point here is here each input binary word connects the corresponding switch either to ground or to the inverting input terminal of the op amp, which is also at the virtual ground. This is the starting point. Each input binary word. Each input binary word means that is DI, where I is equal to 1, 2, and so on and so forth. N connects the corresponding switch, connects the corresponding switch either to ground or to the inverting input terminal of the op amp. Terminal of the op amp, which is also at virtual. Since both the terminals of switches DI are at ground potential, current flowing in these resistances is constant and independent of switch position, that is independent of input binary word. That is a very, very important point here. Next one, find out output voltage I1, I2, I3, and I1, I2, I3, IN currents. I1 is equal to, we know that I1 is equal to VR by 2 power 0 by 2R, VR by 2R. I2 is equal to VR by 2 power 1 by 2R, VR by 2R by 2. That is equal to VR by 2R is VR by 2R is I1. It is I1 by 2. I3 is equal to VR by 2 square by 2R, VR by 2R by 4. That is equal to I1 by 4. I4 is equal to VR by 2 cube by 2R. That is equal to VR by 2R by 8. VR by 2R is I1. That is I1 by 8, and so on and so forth. IN is equal to VR by 2 power n minus 1 by 2R. That is equal to VR by 2R by 2 power n minus 1. VR by 2R is I1 by 2 power minus 1. Therefore, find out output voltage V naught. Find out output voltage V naught is equal to this is the 0 minus here one more important resistance here RF is also there. 0 minus V naught by RF is equal to IT. 0 minus V naught by RF is equal to 80. Therefore, V naught is equal to minus IT into RF minus RF. IT is currents I1 plus I2 plus I3 plus I4 and so on and so forth. IN. Here minus RF. Binary data here DI. D1. I1 is equal to D1 into VR by 2 power 0 by 2R. And I2 is equal to D2 into VR by 2 by 2R. And so on and so forth. Like that. These currents are substituted in that equation. I1 is equal to D1 into VR by 2R. VR by 2 power 0. 2 power 0 is 1 by 2R. I2 is equal to D2 into VR by 4R. I3 is equal to D3 into VR by 8R. I4 is equal to D4 into VR by 16R and so on and so forth. IN is equal to DN into VR by 2 power n minus 1. 2 power n minus 1. R is common term minus RF by R. VR is also common term. D1 by 2. That's D2 by 2 square. That's D3 by 2 cube plus D4 by 2 power 4 and so on so forth. Dn by 2 power n minus 1. Dn by 2 power n minus 1. Here also 2R. In is equal to VR by 2R by 2 power n minus 1. VR by 2R by 2 power n minus 1. Here one more 2 is there here. Therefore, finally, V naught is equal to minus RF by R VR D1 by 2 plus D2 by 2 square plus D3 by 2 cube D4 by 2 power 4 and so on so forth. Here 1 is 2 power 1. Here 2 power n minus 1. This 1 and this minus 1 is cancelled. That is 2 power n. Where n is the number of bits in the digital data. Suppose the number of bits in digital data is 3, 2 cube. Therefore, V is equal to minus RF by R VR D1 by 2 plus here n is equal to means D3 by 2 cube to this one D2 by 2 square and D3 by 2 cube. RF is equal to R. When RF is equal to R, RF is equal to R, V naught is equal to minus VR into D1 2 power minus 1, D2 2 power minus 2, and Dn 2 power minus n. This one is the analysis of inverted R-2R ladder. The most important advantage of current mode or inverted ladder is that since the ladder node voltage remains constant, even with the changing input binary codes. The most important advantage of the current mode or inverted mode of the ladder. The most important advantage of the current mode or the inverted mode is that since the ladder node voltages remains constant even with the changing input binary words. This is the most important advantage. In case of weighted resistor type for DAC and R-2R ladder type DAC, current flowing in the resistors changes as the input data changes. As the input data changes, the current flow through the resistors are also changes. In case of weighted resistor type DAC and R-2R ladder type DAC. Therefore, more power dissipation causes heating, which in turn creates non-linearity in weighted resistor type or DAC and R-2R ladder type DAC. This is a serious problem in both the DAC types, and it can be avoided completely in the inverted R-2R ladder type DAC, because the ladder network node voltage remains constant, VR by 2 power 0, VR by 2 power 1, like that. Therefore, current flow through these branch resistance are also constant, even the binary words are also changes. In weighted resistor type DAC and R-2R ladder type DAC, the current flow through the resistors are not fixed, changes as input data changes. Therefore, more power is dissipated within these resistances, causes non-linearity in weighted type DAC and R-2R ladder type DAC. With this, the analysis is completed.